Hello, everybody. Another lecture. This one's going to be on electrical fundamentals, trying to get us in the right right motivation and get into it as we go week to week and get deeper and deeper into it. So without any further ado, let's go ahead and share the screen. I'll be sharing a PowerPoint with you. And on this PowerPoint, I put together, it's going to cover some of the basics and what we need to know about electrical fundamentals. Now, this is something that I really made a lot of money off in the field. So if you can get the electrical part down, you can definitely make a lot of money. It will piggyback on a lot of the other systems too, as you start your adventure into other parts of the automobile. Now, for you that are not going to get into the automotive field, it's really important too, because there's some things that you can actually do, and I'll kind of touch on this as we go along, where you can actually do some minor repairs on your own car. So hopefully this is going to be beneficial for you. So we're going to go ahead and start. And what I want to do is kind of lay out the objectives of this section I'm talking about. So I want to talk about, electricity and talk, that funny little thing that you can't really see, but it's there because if you turn on a light, boom, you can actually see it in action. We'll also talk about electrons, conductors. We'll talk about electrical measurements, how we know what's where and how we apply it to different theories and stuff like that too. So we'll talk about things like volts, amperage, ohms, and I'll break this down a little farther when we get into Ohm's law in this class. We'll also talk about different sources of electricity. It's not just coming out of a light socket. There's other ways that electricity is actually, I wouldn't say discovered, but it actually is made in a way. And we'll also talk about, like I said before, conductors. We'll also talk about resistance, and we'll talk about some of the functions of resistors. So just a little introduction. This is where you got to have a little bit of imagination, because if I were to say electricity is in that wire there, you would go, yeah, right. How do I know? Well, you can't see it. Okay, so it's something that you have to understand, and that's why we use different types of tools to measure electricity. So every year, more and more, and this is very true, more and more cars get more and more electrified. You've heard about the electric car, and well, the electric car is electrical. Let's put it that way. It kind of sounds funny, but how that actually goes down the road, and it's not using gasoline. Of course, if you get into a hybrid, then it's going to be a dual, propelling type motions and stuff like that. But electricity, it really gets kind of difficult to understand. But when you get it, that light comes on, and you got it. So hang with me. Again, it can't be seen. It only results, is when that does something. It's like turn on the radio, turn on the light, and start up the car. So we know something's happening. It is the only way we can look at it is by how it's detected. Okay, and then we'll get into that. So if we look at a background, our universe is composed of matter, which is anything that actually has mass to it. And all matter is made of about slightly over 100 individual components called elements. So if you take a science class, you really get down into something like this too. So the definition of electricity is the movement of electrons from one atom to another. The dense center of each atom is called the nucleus. So you see this little chart up here right now. I should, not a chart, but a picture of an actual atom. And the nucleus contains protons, neutrons. So protons are positively charged, and neutrons, which are electrically negative. And pretty much that's how it all lays out. And what even in science classes, they like to point it out like a solar system. So in the very center of it, it has the sun, and then as you go out, it's the different planets as it goes out. Well, on a car, okay, we have different inputs, and this is where it goes kind of way back for me too, because when I started in the field, there was not computers on cars, or computers weren't even thought of at that time. Later on, as my progression in the automotive field went on, there was more and more computers involved, and actually there was little bitty boxes. We call them little computers, but they were actually control modules for the ignition system. So that's kind of where it all started. But when we started getting into computer systems, we needed to have some input devices. We'll get farther into computers in this semester as we go along too. But inputs, are signals, telling the computer that certain things are happening. So what I have in front of you right now is a basic a 3-wire sensor, and this one is a actual similar to what do we call a throttle position sensor. And this actually is off your right by either on the throttle body of the car. I'll get a little deeper into that as we go along, or it's at the pedal. And this pedal, when it's moved, it actually has a little variable resistor in this little throttle position switch. And as it goes around, so if you look at the very top here, so we have a reference signal going out, and then we have it going to ground, and then I have a resistance here. So this is kind of like a little resistor, but this one actually has a little bit of a special part to it. What it has is an actual sweeper. So this little arrow here, it actually makes a contact. It doesn't show it, but it makes a contact across this resistor. So this little carbon resistor here goes across, and when they go striking across here, it changes the resistance going back to the computer. So this is actually the signal return. Now, as it does it, it actually sends out a variable voltage back to the computer, and the computer knows that you're accelerating or decelerating. So in a nutshell, that's how that works. But we have a whole lot of different sensors out there. We have things like a speed sensor. We'll get farther into that when we get into the computer part of it too. We also have RPM sensors, air pressure sensors, oxygen sensors, and we'll have coolant sensors. They give all this input into computers so we can actually make a judgment of how much fuel and how much timing to involve. And I'll get more into that as we go along too. So positive and negative charges, the parts of the atom have different types of charges to them, and they kind of orbit around that actual nucleus like that. It kind of goes across. So as it does that, it actually either becomes balanced or unbalanced, and we'll get a little farther into that as we go across here. So if you've ever taken a magnet and have a magnet kind of click together, okay? And with that magnet, we have a south pole and a north pole. So these are two different charges to them. And if you push the south to the actual south pole, it'll actually kind of repel itself. But if you take it, flip it around to that north pole of it, it will actually attract. So basically, two similar poles will repel, where two dissimilar poles will actually attract. So you see on this one where the north and south here, and then we have two souths, and they're pushing themselves apart. And we use that, and we'll get deeper into that too, on how we get certain things to work on our car, how we get a electric motor to work, how we get an alternator to work. All this is part of it, okay? So here I have little ions going out, circling around, and if I have an imbalanced atom, then they can actually they would be free flowing, and they can actually go to another atom. And as they go around, they'll actually be able to gain more and can become more balanced. Well, with different types of electricity, I should say types of electricity, we have different types of atoms. We have, and I should have said atoms, but, and we have a hydrogen atom, which we have like one electron spinning around, and where we have aluminum, which has 13 atoms kind of spinning around, electrons, I'm sorry. And then we have like copper, which is a good conductor. We have 29 electrons, and we'll get deeper into that too. And then we have a silver atom, which actually has 61 electrons. Keep that in mind. So here I have an example of a free and bound type of electrons. So I have this one kind of buzzing around. It's free to buzz or go around, whereas I have this other going around in the valence ring over here, and it's free to go and move on its way. So conductors, like I said before, are really good insulators. I'm not sorry, not insulators, but to conduct, electricity. So like your coppers, some of your aluminums, actually water in a way can conduct too if you have a high enough voltage on it, and it can cause, of course, you to get electrocuted and stuff like that too. So there's different types of conductors. And if you get into like gold is one of the best conductors too, but we use a lot of copper because it's fairly inexpensive. I wouldn't say it's cheap, but it's fairly inexpensive. Semiconductors, which is what is going to do a lot of our work for us. They are materials that have exactly 4 electrons. You remember, kind of spinning around there. So it doesn't have that free flowing going across. So different types of semiconductors like silicon, also germanium, and also carbon. They are semiconductors, okay? So how electrons move, like through that wire. Now, I will put up a very good video from YouTube. It's one of the guys I follow, okay? And he puts out a really good idea, really good theory, and how electricity goes through wires. Now, what you see here is actually not really totally correct, but it's giving you the idea of what's going on. So we have a positive and negative charge, like on our battery, and I'll show you a picture in just a little bit. As the little electrons going down in here kind of buzz around, so this is where we start getting that movement. going across, and we'll talk a little about some other things in just a little bit here too, that will kind of click that light on. But it moves around, and if you really looked at it, it's really not in the center of the wire, it kind of goes on the outside of the wire there too. So we want to turn on this light bulb. We got a battery. It can be a small battery, it can be an automotive battery, but because we're talking about automotive, we're actually going to go ahead and use a automotive battery. So this one actually has a current flowing through, and depending on who you talk to is the difference between conventional theory versus electron theory. I've always went by the actual electron theory, but the automotive world for some reason says that the electrons flow from positive and negative, but really I believe it goes from negative to positive, but really doesn't matter. It's just the way you look at it. And if we connect it, that circuit together, that light bulb turns on. Of course, there's more stuff we put into it. We don't just we don't get up in the morning and plug in our battery first thing in the morning. Hopefully you don't have to, because if you do, then there's probably a problem with the car. But we don't just plug it in and then we go on our merry way and disconnect it when we get to the market or get to school. So we actually turn or push a button that actually starts up the vehicle. Or if you have an electric vehicle, then you're actually just pushing the button and you put it into gear and keep on going. Or you turn the knob, whichever one that you have, vehicle you have. So this is, just showing you it goes around and turns on that light bulb. And we have how we measure movement. So there's a couple things we do. We measure electricity, okay, and we'll get into Ohm's law and fairly soon. We also measure amperage, and they also measure resistance. So if you look at how many amps go across a wire, okay, there is actually 6.8 billion electrons move across the wire, and then we use some equipment to measure that. Okay, and I'll get into tools as we go along too, and how we actually do those measurements. So this is actually what do we call a DVOM, digital volt ohm meter. Okay, and we use this to measure voltage, amperage, and resistance. And it's a neat little tool. You can get them fairly inexpensive. Buyer beware. If it's not sensitive, you might have some poor readings. And I'll go over DVOMs and different types of meters as we go across this semester here. So if I look at this and I see 12.6 volts, which tells me it's measuring probably a battery right now, and that shows me it has 12.6 volts, and we're measuring pressure. Okay, so what pushes those little electrons to one direction to another is pressure. All right, so it is the electromagnetic force, or what we call EMF, is another way to kind of say voltage. When we look at voltage, okay, we put it out in an equation. We normally, instead of writing out volts in all of our equation, we use the letter V. Okay, sometimes I've seen it as E too. When you get into more scientific notation, you might see it as an E. So that means the electromagnetic force. So if you see that, don't worry about it. It's going to actually be like that. So we measure, volts, his abbreviation is actually voltage. So if I look at my my actual chart here. So one of the other things that we measure is resistance, and we measure that in the word ohm, and we use the omega symbol for that as we write out our equations. So ohms is the resistance to flow. So if you have a resistor in place, like what I have up here, this is a resistor, and this resistor resists flow. Okay, and that's, we do a lot of, we put resistors in place. Even if you look at it too, any component that does work for us has a certain amount of resistance to it. And that's how we turn on the lights. That's how we get that motor to go. So we measure resistance also with that meter. And we'll talk more about that as we go along too. And the other measurement we have is amperage. So remember that billions and billions, going across that wire. That's how we measure the guys. And we have sensitive equipment to do that as we go across. So we have our battery, we have our resistance, and we also have the measurement of amperage. That, those guys running across the wire, going across, going back, trying to find their way back home. So we'll get in circuits as we go along too, but it has to be a completed circuit for it to do work for us. So how do we measure? Okay, so this is where we're going to get into a little bit of Ohm's law. So we use in for Ohm's law. We can actually measure, actually calculate watts too. So if we take that amperage and multiply it by voltage, that actually gives us some watts. So they rate a lot of electric components by how many watts does it take to actually go. So this is kind of the equation which I'm talking about. We'll get deeper into this. I want to kind of go over a brief description of electricity as we go along. So if you want to know a little bit of history, who actually come up with the equation and the theory behind watts is actually by James Watt. We call it Watt's law. He was a Scottish inventor. And the symbol is in watts, usually is in a P for power. Okay, and then we have the formula which I just showed you right there as well. So how sources of electricity, this is where it gets to be a little bit fun. Okay, so we have different sources. One of the sources we have is by friction. Now, if you've ever, got got carpeting in your house and you got new stuff. I remember this as a kid, when we got new carpeting in the house, we all buzzed across the carpeting and started touching my brother and my sister and shocked them. Well, that's part of what they call static electricity, of course. But when you kind of move to different materials together, they can actually create electricity. And these are very high voltage, so be very careful on that. So how we measure it is from a galvanometer. We can also have another form of electricity. You've all heard of it. We can actually have light, so where we have solar energy or solar power, and this is where it collects the actual sun's rays to create electricity. We also have pressure. Okay, we push down on a crystal. Quartz is a good example too. So quartz, it can actually be used for different things, watches. Also, we can use quartz in some of our sensors on some of our cars too. So other sources, of course, your battery, it is a chemical reaction to two different materials and a little bit of an electrolyte inside of it. We can actually use an alternator to create an electricity also. And this is a couple of the different things, but how an alternator works is very similar to a starter. Okay, a lot of your electric vehicles and your hybrid vehicles don't have a starter because they use an electric motor to actually start the vehicle. Or if you get some of your older hybrids, some of the Saturns, the early Saturns had what they call a light hybrid, and they used the alternator as a starter. You know, kind of going way back on things like that too. So good conductors, copper, gold, yes, other metals too can be good conductors. Now graphite can be a good conductor. There's some good research on graphite as a new form of a battery to be used in it like that too. Water can be a conductor also. So it can be, it actually could be somewhat of an insulator, but really you don't want to use it as that. So resistors. Now, one of the things about resistors is there are different types of resistors out there. I'm putting up a picture right now of an actual fixed resistor. This resistor actually has the ability to have a resistance that is at a certain ohms or resistance, and it actually opposes the flow of electricity. Okay, so this is basically, we use that a lot in some of our circuits on our cars. We use surface resistors in our computers because we don't want too much voltage going into. We'll get deeper into that as we get into the computer part of it too. And also there is variable resistors. There's 2-wire variable resistors, and there's also 3-wire variable resistors. And I'll go a little bit farther on when we get into more of the components on the computer system as we go along that too. So just a little recap on this. Electricity is the movement of electrons from one atom to another. For current to flow in a circuit or wire, there must be an excess of electrons at one end of and a efficiency on another electron. Okay, automotive electricity uses the conventional theory on most cases. Let's put it out. If you're designing, you got to rethink your theory on that. If you go into engineering, because they're going to get back to the electron flow. Okay, amperage is measured in the amount of current flow, and voltage is the unit of electric pressure. Ohms is the resistance to electric flow, and then source of electricity can be in friction, heat, light, pressure, and chemical. And there's a few other ones out there too, but that's pretty much what you use in the automotive field. All right, so I'm going to head stop the PowerPoint right now. And if you have any questions about this, please feel to reach out to me. I do ask that you replay this as much as you need to. And if you would like, I'll give you a link to actually the YouTube that I actually did this on. All right. Thank you for watching, and we'll be going on to our next part, our next little section fairly soon. Take care now.